let's dive deeper into understanding cold surges and see how they play a crucial role in shaping Singapore's weather. This sudden burst of cold air from the north can bring significant changes to our local climates. Now, let's explore the characteristics and behavior of cold surges and see how they affect Singapore and the region during the monsoon season. Cold surges occur during the northeast monsoon. These surges are caused by the sudden southward movement of cold air masses from the Siberia high-pressure systems. As these air masses move across warmer tropical waters, they create strong northeasterly winds and increase moisture in the atmosphere. In Singapore, cold surges can bring heavy rainfall, gusty winds, and occasional cool spell. While temperature drop only slightly, the impact on rainfall is significant, often resulting in wet spells and even localized flooding.
Cold surges typically occur several times each winter. On average, they last about 5.4 days, with most lasting around 4 days. 70% of these surges last less than 7 days, but there are exceptions. For example, the largest recorded cold surge lasted an impressive 31 days, from 6th January to 5th February 1987. These cold surges play a significant role in shaping winter weather patterns. While most are relatively short, some can stretch much longer, influencing temperatures and weather conditions over large areas. In summary, cold surges are common in winter, with duration that can range from a few days to over a month, making them important events to monitor.
This period where most cold surges occur over the South China Sea, transporting water vapor towards Peninsular Malaysia, Singapore, and southwards towards Sumatra and Java. Majority of the cold surge that are normally cold, that are generally wet but not sufficient to trigger a wet spell. These cold surge days are classified as dry surge. Dry surge events are defined as those not leading to wet spells and where Singapore experienced no rainfall for at least half of the total duration of the event. 2 days before the start of the wet spell is noticeable, there will be a cyclonic circulation between Singapore and Western Borneo. A negative moisture flux convergence anomaly appears in areas around Hainan Island, southeastern China, and Taiwan, clearly in relation to a sizable cold air outbreak from further north in East Asia. This appears as a precursor signal forcing water vapor to converge further downstream across the South China Sea.
Understanding climate change at local, regional, and global levels is crucial, particularly for water management in Singapore. Wet spells from cold surges contribute significantly to our water supply, and predicting whether a surge will bring wet or dry conditions, which is vital for effective planning. By analyzing moisture flux patterns, can better manage our resources. Looking ahead, future research aims to develop indices for cold surge, helping us evaluate how these weather patterns can change due to climate variability. This includes understanding shifts on both short-term and long-term timescales, allowing us to prepare for future climate impacts and ensure a stable water supply.
The Meteorological Service of Singapore issued a study in July of 2019 that large-scale cold surges do not necessarily result in wet spell in Singapore. In fact, some of these cold surge events may coincide with dry weather in Singapore and its surroundings. In the study, dry and wet cold surges events were evaluated. The key differences between these events is how moisture in the atmosphere was moving and changing. For wet cold surges, they found that 2 days before it started raining, there was more moisture in the South China Sea. On the day it began to rain, they noticed a specific weather pattern forming between Singapore and Borneo that helped bring in more moisture. In contrast, dry cold surges showed a consistent pattern of low moisture levels. Studying the large-scale features of these different outcomes may provide positive insights for the benefit of weather and climate predictions, as well as for model evaluations.